Okay, so the definitions that we're pulling up right now are ratio, poor old ratio. Ratio means something that is measured. Measurement, using ratio measurement, is heights, weights, volumes, areas, anything having to do with measured. Interval, temperature. Remember temperature when you are asked about interval measurement, because it's in intervals of 10, 50, 60, 70, 80, 90 degrees. It's in intervals of 5, 10, 15, 20. Now the reason we don't have a natural zero is because we don't know what natural zero is. We can speculate, we can calculate, but we don't know what natural zero is. Ordinal. Just remember, order, ordinal. That means like a race, first, second, third, fourth. Everything has to be presented in what? Order. And nominal means eye color. Well, I thought you said that was qualitative. Yeah, it is qualitative. But how do you measure eye color? Miss Cochran has blue eyes. Okay? Miss McLean has blue eyes, or green. Green. All right, forget Miss McLean. You got blue eyes. Last name? Powell. Miss Powell's eyes and Miss Cochran's eyes are blue. Which ones are bluer? I don't know. How do you put a... Miss Brown, she has blue eyes. How do you know who has the bluest eyes? It's hard to measure. You would have to do on a scale from 1 to 10. And then you have to say 9, 8, 7, 6, 5, 4, 3, 2, 1, whatever. I don't want to use 3 numbers because I don't want anybody mad at me. All right? Now, brown-eyed people have got it made. Because brown eyes are brown eyes and they're perfect. No, I'm just kidding. Green eyes, they're rare. Okay? Green eyes are rare. Gray. Have you ever seen anybody with gray eyes? That's weird. I mean, their eyes are pretty much gray. They're so hazel or so blue or whatever that they're gray. But how can you put a measurement on it? You can't put a measurement on it unless you do some kind of spectral analysis. And you can't do that. So it can't be arranged in order because... And just think of the 3 ladies I mentioned. Who's got the bluest eyes? You can't. You just have to put them in a category of what? 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 Color, blue. Yeah, the blue. They got blue eyes. Blue eyes, green eyes, brown eyes, hazel eyes, and other. Okay? Just make sure you know the difference between the 4 different types of measurement. I don't spend a lot of time on that because it's not critical to you being a master in this class. What is it page 45 that chapter 2 starts on? Oh, we haven't went through 1.4, have we? Let me see, what's 1.4? Okay, random sample. All right, there's 2 definitions I want to give you for random sample. One is random sample, and the other is simple random sample. Now, random sample, there's not a definition of random sample, and I don't want you writing this definition for random sample because it's too long and confusing. Simple random sample is where everyone or everything has equal chance. This is random sample. Everyone or everything has equal chance of being selected. That's random sample. Everyone or everything has the same chance of being selected. A simple random sample, let me give you an example of a random sample first. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, There's 27 people in here. So I break y'all up into groups of 3. 1, 2, 3. This is the first group. 1, 2, 3. Second group. 1, 2, 3. Third group. 1, 2, 3. Fourth group. 1, 2, 3. Fifth group. 1, 2, 3. Sixth group. 1, 2, 3. Seventh group. 1, 2, 3. Eighth group. 1, 2, 3. Ninth group. This is group 1, group 2, group 3, group 4, group 5, 6, 7, 8, 9. And I put each one of your names, group 1, group 2, group 3, group 4, I put that in a hat, and I picked one out. That is a simple random sample because you are what? What's the difference in a random sample and a simple random sample? Random sample, I put each one of your names in a hat, and I pick your name out. That's a random sample. What's a simple random? They're group. That's the difference. So, definition of a simple random sample is each group has equal chance of being selected. Random sample is the most used in probability because it's simple. And a good example of a random sample would be putting all your names on a piece of paper, slicing the piece of paper up into little slips with your name on it, throwing them in a jug, shaking it up, getting one person to pick a name. That would be a random sample. You can't get much more random than that. That's why most of your drawings, when you enter a drawing, is done like that, because it's a random sample. Everybody has the same approach. Now, what if you put in your name 15 times and everybody else puts their name into one? It's not a random sample because you messed it up for everybody because you put 15 names. Now, this is an example of random sample. Now, notice it does not have a page like a notebook, like a page out of a telephone book. There's no way that you can make a random sample out of a page of a telephone book. Why? Because how many pages would be in the Anderson County residential telephone book? 30, 40, 50? And there's no way you could throw a dart or put your finger on one because there's 30 or 40 pages. So the reason they show it on the computer is because the computer has the ability to put all those numbers into one little basket. And you hit a button and it'll throw a number up. And that is a random sample when the computer can do it. The only other way you could do it is to take all the residential, and we're just going to use Anderson County, all the residential telephone pages, and take a razor and cut every little name out of it and put all of those little slithers into a goldfish bowl and pick a name out. That would be a mess. Okay? Everybody see what I'm saying? The computer, the picture of the computer simplifies the actual picking of a phone number because it can go through and do that. Systematic. An example of a systematic random sample would be lining y'all up in the back, and every fifth person I give extra points on the test. That would be systematic. And what would be the reason? Because there is a what? A system, a pattern. Convenience sampling is the easiest, but it's the least what? Accurate. Going outside and asking people that are smoking if they smoke or not. Being a DJ on a radio show and telling people to call in to see what radio station they listen to. The convenient sample can be the most convenient, but it can be the least accurate. And then there is stratified and cluster sampling. Stratified would be like me dividing the class into two groups, male and female. Boom, that's it. Male and female. Stratified, or cluster sampling, would be me dividing the group into two groups, male and female, but then coming back an hour later and finding out that the males and females have divided themselves into what? Two more groups. Nerds, not nerds, or I don't know. Keep thinking stuff. I don't want to think of anything because y'all get mad at me if I do. Alright? Barbies and non-Barbies. The guys would be geeks and non-geeks, or mechanical and non-mechanical. Alright, we only got 4 guys in here, so I mean five right now. 1, 2, 3, 4, 5, 6. So I don't think we're gonna have much of a cluster there. But I guarantee you put 15, 20 women together, you're gonna have some clusters. They ain't gonna sit all together at one time. I give it what do y'all think, 20 minutes? 5 seconds, and they'd be like, they'd already, after a few cacklings, after a few communications, okay, I'm going to go sit over here. And then the other one would go sit over there, and then there'd be a few. Y'all catty. Guys would be like, you dumb as hell. I mean, they don't say anything. Girls don't say anything. They just kind of like, hey, well, you have a nice day. Guys just like, you stupid. So that's what a cluster is. You break a group into two groups, and then they naturally break themselves up into groups. Not a big deal. I don't see too many test questions coming out of a cluster sample. But just in case it algorithmically generates one, you'll know what a cluster sample is versus a stratified. And that's the definitions there. I think that's it for chapter 1, but I'm not sure. Let me look. Oh, no. All right. Write those 3 down on page 27. Retro. Well, y'all know what retro means. What does it mean? Back in the day? Retro country? Retro country music? Retro rock? Retro style? Retro, I don't know what you call it, retro fitting? Retro, whatever you call it. In other words, back. Go back. Go back and look at the records in 1960 to see how many people died of DUI. Died because of DUI in 1960 in Anderson County. That would be a retrospective study. A cross-sectional study and a prospective study are kind of similar because is there any way I can go into the future and get records? Let me tell you, if I could go into the future, I wouldn't be getting records. I'd be getting football scores, racing scores, lottery tickets. Okay? Hubie would be very well off if I could go into the future. All right? So you really can't go into the future, but you can predict the future. Mathematically, you can predict what people are going to do. Give you an example. You ever got behind a car on Wild Hog Road going to Philton, and they're going 35 miles an hour? Or any road. You don't know where Wild Hog Road is? Double bridges right over here. You know where double bridges are? Go over the double bridges, you turn right. That's Wild Hog Road. They call it 187. 187 is out here, dang on, going to the lake, all right? That's Wild Hog Road. I'm just kidding. People say, that's 187. Okay, north 187. South 187 is going to Hartford, or going down there to Shiloh down there in Savage Creek. All right, I have no idea what I was saying. What was I talking about? Oh yeah, you get behind somebody on Wild Hog Road, and you know there's only two ways to go when you get on the end of Wild Hog Road. What are they? To the left, to go to Pendleton, or to the right, to go to Michelin, right? You get behind, you're at 8 o'clock in the morning, you got an 8 o'clock class, and it's like 7:55, and you're on Wild Hog Road. And this teacher will lock the door if you don't get there on time. Which way you think that little old lady's going to turn when you get to the red light? She's going to turn to the left because that's where you're going. How many times have you gotten behind somebody and you're in a hurry and you say to yourself, this slow ass is going to turn left because I got to go left. And I can turn if they don't do that. How can you tell the future like that? Because you have been behind that person, not one time, not the same person, but you've been behind that same slow person when you are running what? Behind. Running left. And that is what I mean by predicting the future. Now, can we predict the future in marketing and business? Yes. In economics? Yes. In fact, there's some economics people, economists, or whatever you call them, that say that we're fixing to head toward another depression. And they do that, and I'll show you. And this is what you call perspective. It's when you take data from now or back a long time ago, and you, let's see, what was I thinking about? You predict what's going to happen. And I think if I could pull it up, let me go here, not Facebook. Oh, where can I put that? Let me pull up. New York Stock Exchange 1920s and present. There is a picture showing. No. Hold on. Stock exchange chart. Graph. It's something like this. No, that's Australia. Comparing, good gracious, where did that come from? Dadgummit. Comparing, graph, comparing. Here it is. Alright, now I want you to look at this. I'm not trying to scare anybody, but this is what we're calling. This is called a, oh no, I hope I didn't just do it. Look at there. This, and I can't blow it up anymore except maybe this way. All right, we all know what happened in the 20s, right? Dang old what? Dang old depression. Well, look at the New York Stock Exchange in 1928 and 1929, and look at the present stock exchange numbers. What do you see? Huh? I know, we already passed it. But what I'm trying to say is, well, I don't know. I don't know. We need to do it more up to date. I don't know. I don't know what this looks like because they said they think that the July, or what is it, January, March, April 2nd. Oh, God. No, that ain't what I thought it was. Anyway, I thought it was my ex-wife's birthday or something. All right. Equates. I mean, that thing says we should have had a crash in April, but evidently we didn't. But I would like to see. I don't know what it looks like now. They don't show it now. Somebody needs to look it up, I guess. I don't know. I was hoping it would show but there was a lot of people here in the beginning of the year that was saying that, oh, we're heading toward another depression in April. But it didn't happen. But look at the similarities though. Look there. Look how it's similar. Makes you think though. But that's what it's a retro. You use an old data here, but you're using the old data to help in the present data to help what? Predict. And that's what you're doing. Okay? You have to research it and see what it is today. I don't know if we could do that. Let me try one more. And today's graph. I guess once they found out that it didn't plummet, I guess they said, okay, we'll bump it. We just won't do it no more. So, they're still, I bet they did. I bet they said, oh, well, didn't happen. Just throw it away. Throw it in the trash can. I guess you'll just have to keep looking for it. Oh, well. Anyway, that's a retrospective and predicting the future, or trying to predict the future. Is this still the same one? Yeah, this says 4. I just wonder what happened in the 4th month. This is 1920s. Oh well, they just threw it away after it didn't happen. They just threw it in the trash can. That's usually what happens when math people they can't get something to work out right. They just throw it in the trash can. Well, y'all can keep looking for it. I ain't got time to look for it. But anyway, that's a good example of when you actually use really. Even Pearson is starting to log me out of stuff. I mean, it's a conspiracy. And we all know whose fault it is. Whose fault is it? Yep. Always Bush's fault. Okay. Hold on. I gotta log back in. Well, let me log in. Doofus. You know, after 4 classes, I'm about losing it. I need some drugs. Not stupid drugs. I mean, I need some dang old something to make me feel better. All right, frequency distribution. What is a frequency distribution? A frequency distribution is a 25-cent word for what? A chart. Let me bring this down a little bit. And what? You trying to run my class? Is that what you're trying to do? Can I be in charge? Is that all right?
Oh yeah, you're in charge.
No, you try and tell me what to do. Get out of my classroom. All right. Where's my dang old? There it is. A frequency distribution. I try. I do so much for y'all. I really do. Y'all ought to be thankful. I'm one of the teachers that actually go through all of this for y'all. Notice I said warning. What the heck?
It's not looking
I know it's not. It's supposed to be. Somebody's done messed with the freaking projector. Unless. You know, I believe some of these people could break an apple with a banana. Now it's going to be screwed up. I mean, why don't teachers just leave the daggone stuff alone? See? Still not right. That dang bush. You know, I just don't know how we're going to get on when you know, we let another president. It's still going to be Bush's fault, isn't it? Everything's Bush's fault. All right, now, the frequency distribution is, sorry about that, is a 25-cent word for a chart. If I go over here and I make a chart and I put blue, brown, hazel, and green. All right, I'm going to ask y'all to raise your hands high. How many people have green eyes? Raise your hand high. We got 1, 2, 3, 4, 5, 6, 7. 7 people have green. How many have hazel eyes? Raise your hand. 1. You ain't got no hazel eyes. 1, 2, 3, 3. Okay. How many have blue eyes? 1, 2, 3, 4, 5, 6. Why did I ask for those 3 before brown? Because the rest of us have what? Brown. How did I know that? Because we are good. That's why. No, it's just this is the way it is. So if ever how many I count while we're 27? So how many is that? 10, 16. So that means how many? 12, 9, what? 11? Okay, is there anybody else that's got any other color eyes? Contacts, anything? Gray, green. Usually your blue eyes or your brown eyes. Brown eyes usually are the norm. Okay, now again, you can't measure who's got the brownest eyes because and hazel eyes, or you can't do that unless you say, okay, out of the blue eyes. I pick on blue-eyed people because they think they're so beautiful. The blue-eyed people, if you wanted to do that, then you would have to say, okay, from a scale from 1 to 10, what does everybody think about this person? What does everybody think about this person? What does everybody, and you have to do that. And you have to do it with brown eyes. What would be hardest? The brown eyes. Brown eyes would be hardest because of the brain. It's just hard to what? Hazel. You ain't got no hazel eyes. All right. But anyway, what is this? This is a frequency distribution. It's a chart. That's all it is. It's a chart. It has classes. It has a head count. As long as it has classes and head count, it is a chart or a frequency distribution. Here's your classes, and here's your head count. Same thing with ages. If I did, I don't like to do these because let's go 18 to 20. and 21 to 22. And then 22, 23 to 24. No, that should be 24. I have to rank the same class width. 28 to 31. Okay. So here are my classes. And 2, 4, 8, 10. And there's my head count. And that is a frequency distribution. I bet you $1 somebody in here had no clue what a frequency distribution is, but they knew what a chart was. Because there always are people like that. A frequency distribution is just a 25-cent word for a chart. Now, what can we get from a frequency distribution? Well, we can get a lot of things. One of the most important things to get is called the class width. What page are we on, people? Say again?
45.
We're on page 45. Class width is very important. The mid-range is very important. Now, the mid-range is going to be very important when we find in frequency distribution mean and standard deviation. And we're going to have to know that. So that's two things. Those are two important things. The other things are kind of whatever. They're not really important. One is called the lower class limit. And the upper class limit. And I'm not even going to write a definition for it. Because once you see it, you're going to know what it is. And then the other is called the class boundaries. And when you see it, you're going to know what it is. But the only thing on the class boundary that I would like to tell you, if you start off with whole numbers, you're going to use tenths. And if you start off with tenths, you're going to use hundredths and so on. And I'll explain that in just a minute. So when you see a frequency distribution, you don't have blonde brunettes and redheads or blue-eyed, brown-eyed. In other words, if you've got classes like ages, then you're going to have to find these things. How do you find the class width? Subtract classes. And I'll show you how to do that. How do you find the mid-range? The lower class limit plus the upper class limit divided by 2.
Is that
Same thing. Now, what I'm going to do is I'm going to pull up page 45. Is it 45 where that there has been an error reported? Okay, well, fine. All right, look at that table, or look at this frequency distribution right here. I'm going to show you how to find everything you need to find from that frequency distribution. So go ahead and write it down in your notes and use another page. A whole page, because you need to write all this down and highlight it. Okay? Give you a couple of bits. Oh, excuse me. All right. So, some of you may have never seen this before. Some of you are like, I don't know how to do it. Well, it's not that bad. Believe you me, it's real easy. I'm trying to pull it back up. Can't pull it back up. Where is it? There it is. All right. First thing you need is your class width. Your class width is 50 minus 70, 70 minus 90, 90 minus 110, 110 minus 130, 70 minus 50, 90 minus 70, 110 minus 90, 130 minus 110, 149 minus 129, 129 minus, and take the absolute value. And what is that? What's 50 minus 70, absolute value? 20, Hubert. That's right, class. So, the class width is equal to 70 minus 50, which is 20. Or if you take 50 away from, or 70 away from 50, take the absolute value. Because class width is a distance, and distance can never be what? Negative, Hubert. That's right. Distance cannot be negative. Y'all supposed to answer these questions. It's not rhetorical. All right? So, how do you find the midpoint? Or the mid-range? Well, the midpoint or the mid-range, whatever they call it. Midpoint, mid-range. You take the lower class limit plus the upper class limit, and you divide it by 2. Well, what is the upper class limit? No, right here. Here's the lower class limit, here's the upper class limit. Here's the lower class limit, here's the upper class limit. Here's the lower class limit, here's the upper class limit. Not a big deal. The low number is the lower class limit, the higher number is the upper class limit. So 50 plus 69, I have no idea what that is. What is it, 120? What is 50 plus 69? 129? What is it? One what? 119, so 120 would be 60, so that'd be 59.5. Somebody help me out. Let me just write it out because y'all are still thinking. Plus 69 over 2 is equal to, what does that come out to be? 59.5. Well, Hubert, you got 4 other classes you got to find the midpoint for. Add 20 to it. 20 is class width. Add 20 to it. What's 59 plus 20? 79 plus 20? 99 plus 20? 119 plus 20? So then put the 0.5 on there and you got them all. Now you can calculate each one of them if you want to, but that's a pain in the butt. All you got to do is add the class width. Capiche? Now, what about the boundaries? The boundaries are real simple. Do we have whole numbers here? So just find your first one. What is right before 50? 49, but you can't do 49 because that's a whole number, so you got to go to the 10. 49.5. Then add your class width. What's the next one? 69.5. 89.5. 109.5. 129.5. 149.5. And that's how you find your boundaries. Capiche? All right, so let's do one from scratch and see how well you do. I think you'll all fail, but we'll go ahead and try it. My plan's on you failing. I hope you fail, but anyway. Well, here we go. You do number 5 on page 51. Number 5 on page 51. Y'all do that one.